Hello everyone, my name is Yeremia and now I'm going to explain to you about section C, the real world application in our calculus assignment. So this is my name and then this is my student ID. So let's just go to the problem here. Due to a storm, air traffic control instructs the pilot flying at an altitude of 4 miles to make a 90-degree horizontal turn while climbing to 4.2 miles. The path of the plane during the maneuver is modeled by this formula. This formula. Okay, so this formula is the path here. The path, or we could say it's a distance formula. And then where t is in time in hours, and then all the distance are in the miles. Okay, so the first question is we need to find the speed of the plane during the maneuver. Or we have to search for the magnitude of r accent t, the vector r accent t. Okay, so let's just go. As I say here, the distance, this is the formula of the distance, and how do we get speed from this formula? All we have to do is just do this. So if we derive the RT by the t, and then it will going to be a speed. If we are derive the speed, the result of derivative of r vector t, it becomes to the acceleration. So the point is, all we have to do here is only to derive this formula, and then we can get the speed. Okay, derive this formula and then search for the magnitude. Okay, so this is the vt, or the function of speed. It is the derivative, or d over dt of the vector rt, which is minus 100 pi sin blah 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 blah. And then we have to find the formula, the magnitude, sorry. We have to find the magnitude. So just using a normal magnitude formula, we just we make this into a squared. We power it by 2, this one also, then this one also. Okay, so after calculation we got this. So the unique thing we found here is this one. So there's a sine square 10 pi t, and then cos square of 10 pi t, and then we got this formula. The sine square x and cos square x is equal to 1. So this is also because both of this degree are squared, so we can just assume all of this as x, and then we got 1. So this one plus this one is 1. Then it's 100 pi squared times 1 is just the same. And for the 0.2 squared is 0 sorry, 0,04. And then for the 100 squared we just add 2 more 0, which is 1000 pi. Or 10,000? Oh yeah, 10,000 pi. Okay, so here we're going to calculate the pi using this. Wait, I was using the pi is equals to 3.1416. So we squared this one as this. So we squared the pi, and we got the pi squared times by the 1000 is this one. So all we have to do here, it's a 10,000. Oh yeah, it is a 10,000. So pi squared times 10,000 is this one. So we only have to add, this should be add, not times. So this is at 0.04. So times, wait, oh yeah, this is times. Okay, sorry, this is times. So this is 1, right? So 100 pi squared times 1 times 0.2 squared. I need to, okay, this times by 0.04, and we got this. Okay, so it's how to say this one? It's just it's not the exact value, but it is the close value. Okay, so let's just go to the section B. In B, we want to compute the tangential and normal components. So the tangential and normal components of acceleration, which is at and an. and which one is 0 and why. So from AT and AN, there's 0. We don't know if the 0 is AT or the 0 is AN, or it's both are 0. We don't know, so let's just count it. Okay, so the acceleration vector is v, the vector v we derive with t. So the vector v is this one. Wait, yeah, this one, all of this, then it derives by the t, and then we got this one. So 1000 pi squared times cos 10 pi t minus, oh, this is comma, there is two value in the vector. So the first one is this, and the second one is minus 1000 pi squared sine 10 pi t. Okay, so as this formula say, like this formula we derive, this formula, if we derived it by t, we got speed. And if the speed formula we derives again by the t, we will get the acceleration. So we want the acceleration in v point, so we have to derive the vector v again. So it is v accent. So the v accent is equals to this one. So this is the acceleration formula. Acceleration. Okay. Then we want to search for the tangential acceleration formula. So this is the formula of the tangential acceleration, and as we can see here, it is the derivation of v vector t, the vector of v, and then we find the magnitude of the vector of v. But if we see here, the vector of v, the magnitude of vector v is a constant at 314.2 miles per hour. So if we derive a constant, it just becomes 0. So that's why the AT here is 0, because the result of the magnitude of VT is a constant. Okay, so we're going to the normal acceleration, and this is the formula of the normal acceleration here, and this is AT squared minus A squared t equals to it is equals to AT. Oh, the square is until here. Okay, so if we look at here, the A squared t, this one, it is a 0, right? So A squared t is equal to 0 squared, which is still 0. And we just input the AT here, so we don't look at the A squared t, we just look at the AT here. Okay, oh, this should be a magnitude, like here. Like here, okay. So all we need to do is just, we look at the AT and find the magnitude for the AT is this one, so 1000 pi, blah 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 blah, and then we find the magnitude is just their normal formula with using the root and then squared for inside the vectors. And when we count, we got this one, which is when we translate it into a real number. No, not a real number, but we translate the pi into 3.1416. It's become this one. Okay, so for the conclusion, the speed is a constant. It's at 314.2 miles per hour as this one. And this is the speed. This is the speed. Okay, and then for the tangential acceleration is 0. So this one, the tangential acceleration is 0 because the result of vector v, or the the speed is a constant. It's 314.2, so the tangential acceleration is 0. And for the normal acceleration, as what we count, the newest one here, the normal acceleration we got 9,869.6 miles per hour. And yeah, that's it then, normal acceleration. Okay, I think that's all for me, and thank you.